My name is Demetrius, and the question I was asked was, why do we often use steady state conditions when analyzing heat transfer problems? Now, first we need to know what that condition actually means. All it's doing mathematically is it's setting that the change in temperature over change in time is zero, which is going to take out any transient functions. Like for example, the lump capacitance has that transient point of time being in that equation. And in doing so, it makes the problem go from being a more difficult ODE into a simplistic algebra equation. But in turn, this does take out some of the real life problems that we want to know of when we start up, say, a car engine, when it's going to reach that maximum heat. But this does help in turn looking at long time for that engine, because most of the time when we're analyzing problems, we want to learn the long time effects of the temperature change. So we just set the steady state condition, we look at when it's already reached its final temperature, we analyze it, and then we know that final data. We know that final value that we need to know. This is used a lot for electronics. Heat exchangers, we do this sometimes, as well as car engines, like I said earlier. This just makes that simplistic process. From changing that into steady state, we also need to think of, blanked on that one. So in conclusion, we often set steady state conditions on heat transfer problems to make it a lot easier to analyze and not make it more complex for us to solve. Thank you.